Graphing quadratic functions in vertex form. All right, so vertex form of a quadratic is set up the following. So if you recall, the parent function for a quadratic is x squared. And here we have a variation of that. And we've seen a little bit of this before when we did transformations. So now we're looking at what we were looking at before when we did transformations, and we're talking about exactly what those different points and those different transformations mean. So when we have a quadratic in vertex form, it looks like such. The vertex, which that's this point on the function, is at hk. The axis of symmetry then, because this function is symmetrical, mirror image, the axis of symmetry is the vertical line at x equals h. The graph opens up if a is positive. So if a is positive, the graph will look like such. If a is negative, the graph will look like such. So a little bit better drawings than my drawings. Here you have what I just attempted to draw. You've got your axis of symmetry in the middle. Here's an example of a is greater than 0 or positive, and you have the parabola opening up. And here you have a is less than 0, and so you have the parabola opening down. Now, on this next slide, I will repeat this. When we have a is greater than 0 and the parabola is opening up, this point right here is our minima. And then over here, when we have a is less than 0 and it's opening down, this is our maxima. So this is the minimum value for this function, and this is the maximum value for this function. So here I have it typed out for you. Go ahead and pause the video if you need to write this down. All right, so let's do a couple examples. And I'm just going to put this over here so that I can reference this and point to it as we talk through this. So here's vertex form. So we have to figure out what we have in relationship to vertex form. So there's nothing in the parentheses here. And there isn't a number out front so much, except there's an understood 1. So I'm going to write my 1 here. So my a is 1 in this case. There isn't an h, not written anyway, which means it's 0. So x minus 0 squared. And then here at the end, we have our k term. And it has to be written in the term plus k. So I'm going to write plus -4. All right? Now, I know that my vertex is at hk. And I'm also going to make a table with points up here to keep track of how many points I have. I need to have at least 5 points before I graph. So the vertex is at hk. Well, h is 0 and k is -4. So my first point is 0, -4. The next thing I need to do is find my y-intercept. The y-intercept happens when this function crosses the y-axis. Any place on the y-axis, x is equal to 0. So if I have y equals 1 and I want this point, it's 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So to find the y-intercept, x must be equal to 0. So we're going to plug that into our function. So y equals 0 minus 0 squared plus -4. All right, 0 squared is 0, so we have y equals -4. So next point is actually the same point, right? So my vertex is on the y-intercept. Now I need to find my x-intercepts. And for the x-intercept, y must be equal to 0. So this is 1, 0, 2, 0, 3, 0, 4, 0. So y must be equal to 0. And again, I'm going to plug it into my equation. So 0 equals x squared minus 4. Solve for x, so 4 equals x squared. Square root of both sides. Remember that when we take the square root, our answer is plus or minus that answer, because if I take -2 squared, it's going to give me 4. And if I take +2 squared, that is also going to give me 4. So I have 2 more points here. Oops, wrong side. So 0, -2, 0, +2. So I actually have 3 points so far, which means I need 2 more points. So at this point, I can kind of pick whatever I want. Usually it's easiest to pick things on either side of the vertex. So my vertex is 0, -4. So I'm going to pick +1 and -1 as my 2 additional points. So +1 squared minus 4 is going to be -3. And then -1 squared is still +1, minus 4 is -3. So now I've got my 5 points, and I'm going to graph over here. So I've got 0, -4. I've got -2, oops, -2. Oh goodness, I did this one backwards. Okay, let's try this again. So 0, -4. There we go. That makes more sense. And see, I knew something was wrong because, again, it has to be symmetrical. And if it would have been right here, it wouldn't have been symmetrical. So then we've got -2, 0. So that's this guy. +2, 0. And there's that symmetry. And then we've got +1, -3. Oops, -1, -3. So this is another reason that we should always use pencil. It's just the pencil doesn't show up well on the video. So I've sketched my function. And the only other thing I have to do is talk about the axis of symmetry. So the axis of symmetry is the vertical line at x equals h. Plus, visually, we can see that. Its axis of symmetry is where you have that mirror image. So x equals 8, which in this case is going to be x equals 0. This is our axis of symmetry. And then we need to talk about whether we have a maximum or a minima. So we have a positive a, and therefore our parabola opens up. So this vertex point right here is our minima. Okay, I'm going to end this video, and then you need to go to the next video for the next example.